Vlsi lab. So in this we will going to create three experiments simultaneously. That is, we will going to create D flip-flop, SR flip-flop and the JK flip-flop. Okay, so here this is the window for the D flip-flop, and here this is for the JK flip-flop, and this is for the SR flip-flop. Okay, so this one SR flip-flop and JK flip-flop. So just go to file and create new project. So this is for the D flip-flop. So D, just give as a DFF D flip-flop and click next, finish. Okay, so this for the D flip-flop, and here go to file and create new project, and this is for the SR flip-flop. Okay, then click next, click finish, and here go to file, new project, and here JK flip-flop. Okay, so click next, click finish. Even we are going to do all these in the EDA playground also. So before that we do all three things in the ISE project navigator, that is Xilinx ISE tool. So for that, now we just created the D flip-flop, SR flip-flop and JK flip-flop. There's the project. Now just go here and click on this add new source and click Verilog module, and here we need to have D flip-flop. Okay, so then click next, click finish, and come here. So here just click on this and click a new source. Okay, add source, no, we just need to click new source, click new source, and Verilog module, and here this is the SR flip-flop, so SRFF. Okay, then click next, click finish, and here go to file, no, not file, just click here, right click on it, new source, and Verilog module and JK. Okay, so JK flip-flop, click next, click finish. So now we have the editor window here. So D flip-flop, so for the D flip-flop, what is the input? Okay, so what is the output from the D flip-flop? Q and the Q bar. And what is the input for the D flip-flop? D is the input, and we even have another input, that is reset. Okay, so we have the four. Okay, so four kinds of things we have, Q, QB, D and the reset. So now we need to mention the output and the input for this one. And okay, so another thing, we have the clock. Okay, so I just forgot the clock. We need to have the clock, the five things we need to have. Okay, so Q, QB, D, reset and the clock, that is the D flip-flop. So now you can just see all these flip-flop. Just go here, D D flip-flop. So we can see the D flip-flop diagram. So this just like okay, so D, clock, Q bar and reset. Okay, so a reset is not shown, so a reset. Okay, so inside the flip-flop we have the reset. So now we just need to mention the output and the input. So output, okay, so output, output. So Q comma QB. Okay, these two are the output and input. So input is reset and D, and clock, only one bit input, that is the D and clock. Okay, so then we need to we are using the behavioral style. So reg, the output Q and the QB has to be in the reg, Q comma QB. Then always okay, so here always at, so it is the positive edge D flip-flop, so pos edge of clock, and it is the synchronous reset. If they ask for the asynchronous reset, then we just need to have or REST. Okay, like this we need to have. If they ask for the asynchronous, that is it is not related to the clock, then we need to have like this. Otherwise we need to have the reset inside the always block only. So here begin, and here is the end. So we just maintain the indentation. So here in the begin, so if reset, if reset rst. Okay, if reset, then what is the output? So the output is q. Okay, q is equal to 1 tick b0. If reset, 1 tick b0 is the output. So irrespective of the input, the output has to be 1 tick b0. Otherwise, okay, so else what we need to do, the q is equals to output is equals to output follows the input in the d flip-flop. So q is equal to d. What is the d? Input. So output is follows the input, so q equal to d. Okay, so this is the else block. And after that, okay, so this is the d flip-flop. Then after we need to have, okay, if else, okay, so this thing, and always the qb, that is the complement, qb is equal to complement of q. That's it. Okay, so this is the simple version of the d flip-flop. Just save this. And okay, so if reset, q equal to 1 tick b0, else q is equal to d. If there is no any reset, then q equal to d. Then qb is equal to not. This is always okay. So if it is an if or else, qb is always not equal to q. Okay, not of q. That is a complement output. So now just save this, and there is no any errors. Then just add the new source, and here we need to have the Verilog module and test bench. So test bench is d flip-flop tb test bench. Then click next, click finish. Okay, so test bench we will write after completing the module for all these flip-flop. So another thing is, here we have the SR flip-flop. So now let's come to the SR flip-flop. So in the SR flip-flop, what are the output? So one is the SR output. So this we consider it in a array. So SR, this is one input. Okay, so our output we mentioned q and qb is the output, and SR is the input, and clock is the input, and what else? The reset is the input. Okay, so now the output is q. Okay, so output is q comma qb, and input is 1 is to 0, that is the 2-bit 1 and 0 of SR. Then we need to have input, that is clock and reset. Okay, so now always and we need to mention the reg q comma qb. Okay, then always so here at and passage of clock. Then so we need to have begin and inside the begin we need to have if reset. Then we need to assign q equal to 1 tick b0. Okay, so 1 tick b0. Else, so now else begin and so here in the else block we need to have the SR. Okay, depending on the value of the SR, we need to assign for the q. So we just take this case SR, and inside the case so okay, so a case means default out. Okay, so default q equal to what's the default? Default q is equal to 1 tick b, simply anything you can write. It will not going to this default case. So and end case. Okay, so another thing is the end case. So this is the syntax for the case. Then inside the case we will going to have SR. So that is if it is 2 tick b00, if SR is 00, then q is equal to if 00 means no change, so q equal to q, that is no change. And if 2 tick b01, then q is equal to low, that is 0. If 2 tick be 1 0, then Q equal to high, that is 1. If 2 tick be 1 1, then in the SR flip flop Q will be invalid, that is 1 tick be Z. Okay, so this is what the conditions we have. This for the SR flip flop. So now AND case. Okay, and we need to have okay, so and these things we can just have it over just indentation. Then is the AND case. Okay, so after that here this begin and end is not needed, because this case is only one statement, right? That's why it is not needed. So after the else, okay, after this else can have this one here. Then after this always this QB is equal to complement of Q. Okay, so just save this, and if any error, so here it is giving error. So to take syntax miracle, what is giving the error? Okay, so this is Q. Okay, 1, it is not 1 equal to 1, this is Q equal to 1, so there is no error now. So yeah, this is what the code we just need to write for the SR flip flop. So similarly, let's write for the JK flip flop. So for the JK flip flop, it is similar to the SR flip flop. So what I will do means, I will just copy till here. Okay, I will just copy all these things, same code. I will just copy in the SR flip flop, copy in the JK flip flop. So here JK we need to change, and here JK, and here also we just need to change to the JK. So the difference is here also we just need to make JK, and the difference is whenever in the JK flip flop the 1 1 condition occur, there is no any invalid, it will just toggles, that is not of Q, it will just toggles. Only this one change we need to do, it will finish the JK flip flop. Okay, so now we need to have the test bench for all these things. So first let's come to the D flip flop again. So here we have the test bench file for the D flip flop. So just copy these things. Okay, our usual method, we just copy this output and the input to the test bench at the beginning, just to write, and here we need to have the IR, that you need to remember, that is input means reg, so reset, and D comma clock. Okay, then wire, so this for the output Q comma QB wire. So after that we need to have we need to instantiate this one DFF. So we can just copy this thing and just copy down this here, then here DFF and UUT. Okay, unit under okay, so UUT, then you can just remove this our reference things. Okay, so now we need to have initial and begin, initial begin, and here is the end, then clock equal to 1 tick be 0. So forever hash 5. Okay, so forever hash 5, clock equal to not of clock. So this clock we needed for all these SR and JK everything. So okay, so this then after this what we need to do, so we need to assign the D values. so d equal to 1 tick b0, d equal to 1 tick b0, then okay, so not here, this is the clock, right? Okay, so this is just run for the clock. Then here we just have initial, then begin and end statement, and inside this, so initially we have d equal to 1 tick b0, then after 20, okay, so after 20 we make d equal to 1 tick b1, then after 20 we make d equal to 1 tick b0. Okay, and here initially at the beginning, the reset equal to 1 tick b1 we will make, okay, so that the output is set to the 0, 1 tick b1, and after hash 10 we just make reset equal to 1 tick b0. Okay, so now hash 20 d equal to yes, just save this, and similarly I'm just copying this same content for the this SR flip-flop. So just go here, click new source, and click Verilog module srff and tb test bench, click next. So here we just need to have here this is srtb, and we have okay, so this is srff, okay, srff tb, and this is sr, okay, so srff, sr flip-flop, so sr flip-flop and qbd, and instead of d we need to have sr, and here okay, so here instead of d we need to have reg 1:0 of sr. Okay, so then clock, this will remain same, and here sr is equal to, so initially we will make sr equal to 10, okay, so that 10, so that it will be set, output will be set, q equal to set, otherwise we cannot able to trace the output now. So reset equal to 1 tick b0, okay, hash 10, then after that we'll just change sr equal to 2 tick b 01, that is reset, then we can just change 2 tick, okay, b00, no change, that is sr. Okay, so just save this. Okay, so select simulation and select this one, and just check behavioral syntax, any error, no, there is no any error in the SR flip-flop, and similarly in the D flip-flop also just select this and check simulation, and here just select this, okay, then select here, and just test bench you select, and behavioral check syntax, so there is no any error. Now let's come to the JK flip-flop, that's similar to this SR flip-flop. I'm just copying this to the JK flip-flop, and here we need to have right click on this new source and go to Verilog module, then JK underscore TB, and click next, click finish, and here we need to have that same. Okay, so here this is JK, and here we need to have JK and QQB, and here we need to have JK, JK reset clock, the similar thing we need to give even here, so QQB JK clock reset. Okay, so here we give clock reset. Okay, so clock reset, so clock comma reset, so otherwise it will give us the error. So give it in the same order. Then here JK. So then here also we just need to make JK, and here also we just need to make JK, and after 20 okay, so after 20 what we do means again we make this as 1 1 so that it toggles. Okay, so after that save this file, and so here reset and clock will be there. Here the clock and reset, so here also just check what file is it. So just click over here, like clock and reset, what we have in the test bench. So reset and clock, just place it clock and reset in the same order, just place it clock and the reset. Okay, so then control save. Then in the D flip-flop, so here this has to be reset and clock, and here also we have the same thing, reset and clock. Okay, now we just need to simulate these things. In the JK flip-flop, so go to simulation and just click design. Okay, so just select this test bench. Okay, then check behavioral, check syntax. Okay, so this is SR, no, it is JK, right? JK flip-flop, so JKFF. Okay, so JKFF, and save this. Now it's fine. Okay, UUT, check syntax. Okay, so now here also this is there. Okay, so now let's simulate all these files. So first one is this D flip-flop. So let's simulate the D flip-flop. So this is the D flip-flop we have. So now go to the clock. Okay, so just okay, just have this. Okay, I will just make like this and just go to the reset, and okay, so initially we can see here, we can see, if we just observe the one output, we can see reset is equal to 1, then okay, reset is equal to 1, so that the output will become next. Okay, so the 0 and 1, Q is equal to 0, QB equal to 1. So after that the reset is equal to 0, and D equal to 0, clock equal to 0. So the output has to be in the same. Then okay, so just go to D, and here we can see D equal to 1, D equal to, okay, so here D equal to 1, the clock is not 1, it is 0. That's why we are in the same before state. But when the clock equal to, okay, so now we can see when the clock is equal to 1, this D value appeared in the Q. Okay, so that's why Q equal to 1. So this is how the D flip-flop will going to work. So now let's see the SR flip-flop, that's this SR flip-flop. So just simulate behavioral syntax. Okay, so in the SR we have like this. Now we just need to okay, so now we can see this is 0. Now the clock is equal to 1, this is reset. Okay, so clock equal to 1, now resetted, and now we can see the SR, which is 1 and 0. So the output is 1, and the QB is 0. So after that okay, so after that 0 1, so 0 1 means the output has to be 0, the output changed to the 0. Then 0 0 0 0 means no change, so there is no any change. So this is the SR flip-flop. Then the final one, last one, is the JK flip-flop. So for this JK flip-flop, let's go to the simulate behavior model, and Okay, so here also, okay, here it seems something wrong. Everything is dead. Let's check what is wrong. So JK flip flop and QQB JK clock reset. Okay, QQB JK clock reset, these things. QQB JK clock reset, and in test bench QQB JK clock and reset, QQB JK reset and clock, JK flip flop test bench. So initial begin clock equal to, then JK reset. Okay, so everything looks fine. Clock reg q comma qb, q and qb is equal to, okay, so these things are fine. Q equal to q, JK flip flop. Okay, so reset. Okay, clock and reset, and here is also the clock and reset, QQB JK, QQB JK. So we will just again simulate this. Why it's giving like that, I don't know. Yes, now it's proper. So just go to the reset, and okay, so initially the reset is at 1, then the reset, it is resetted now. So now we have this JK 01. Now we need to have the clock. So JK is 10, that means the output has to be high, so the Q is high and QB is 0. Then after that 01 JK, so the output has to be 0, and this is 1. 00 means no change, it will remains like this, and 11 means it has to toggle, so 10, you can see it is toggling. So this is how the JK flip flop works. So now in the this one, okay, so I'm just going to show for the JK flip flop. Remaining two you just need to do in the EDA playground. It is similar, all these things are similar. So for the JK flip flop, let's have this one. Okay, so where is that? This one. Okay, let's have this one here, and we have here. Okay, so this is for the JK flip flop. So this is the test bench. I just copying in the, okay, let's refresh this one, and here we just need to have the test bench, and this is the JK flip flop module code. So that one we need to have here, and here I have a small like this dump waves, so it is also there in their website. So we just need to put that here, and let's save this as JK flip flop, and click save, and please select valid simulator. So the simulator is LVDAC simulate this. Okay, then click save, then it is saved. So now just click okay, so this is we will run for 100 nanosecond, then click here and click run. Okay, so it has to give the output. Okay, so open EP wave, this we forgot, so we just click again run. Okay, so if it is not giving, just check change this Alvidog. Okay, so this error is coming recently, so just change to Synopsys VCS or any, then again just click stop and click run. Okay, so now it will give us the output waveform. Okay, so okay, it is asking for some licensing something. So let's see this. Actually it will run. Okay, so it will give us the waveform also. It has to generate the waveform. It's running. Okay, let's just refresh this. It has to produce immediately. It will produce, it takes some time sometimes. So here, okay, then click run. Error, you cannot have more than one simulation runs, please wait. Okay, just refresh this and okay, each run has maximum run time. So where is that run time now? Okay, so I just need to go to the playgrounds, and here I guess something is running. uh, okay, so let's just refresh this and run. Okay, so now it's running. Okay, so it has to open the waveform window, but it is not opening. So what we do means we just select the some other tool. Okay, then we just run this. Then okay, so EP waveform is not opening. You try this out. I will share the link for this. It will open the EP waveform, but for a time being it's not opening the EP waveform. So it has to open one window, EP waveform window. So I think because of slow internet or some issues. I hope you understood this. Thank you.